Hi, everybody. I'm going to present section 2 of chapter 5 of the PDE 4 NQF level 4 exam. I'm going to start immediately to share my screen with you. Sorry, my camera is off. Sharing my screen with you guys, and then I'm just going to open the PDF document. You should see my screen at the moment. Section 2, we're going to discuss probability. Now, I'm going to go through probability with you. Probability is an event that happened randomly or by chance. It might still happen, okay? For the examples in this exercise, they use a dice, okay? And a dice has got 6 sides, okay? Now, the probability of you throwing a number 1 on the dice is 1 chance in 6 because it's got 6 sides. So this can be written as 1 to 6 or 1 double point 6, okay? The odds of throwing a certain number with 1 dice are 1 to 5 because you can that is 1 chance of throwing a 1 and 5 chances of throwing any other number. So I hope this makes sense. It's quite logic. So you have 1 chance of throwing a 1 and 5 chances of throwing any other number because there's 6 sides, okay? There, I made a note for you on statistics. Probability is used to describe the likelihood of a particular outcome or an event occurring. Probability is usually expressed as a number between 0 and 1. 0 is an impossible event and 1 is a certain event, okay? I'm not going to do the activities. I encourage you to do the activities because it will help you to get familiar with the content, okay? There's another definition, a proper fraction. That is the relative frequency of an event, and it will always be a proper fraction. It will always be from number 0 to 1. The more certain an event is, the closer the fraction will be to 1, okay? The more unlikely an event will happen, the closer the fraction will be to 0. So you can get minus 0.8, and that is closer to the fraction of 1, just, just to explain. Okay, the fact that you can only determine the probability of an event after a large number of trials brings in mind 2 important topics, okay? You must have confidence in your sample size, okay? The smaller the sample, the more unreliable your findings will be. This is now in statistics, it's a general rule of thumb, okay? So activity 2.1, if you go and do that activity, you found the relative frequency of probability of throwing the dice, throwing a 4 on a 6-sided dice, okay? This type of activity is called an experimental study of a probability model, okay? This is just definitions for you. Probability models can be used to predict weather patterns, trends in markets and growth patterns in the housing market, spread of a disease, governments can use it for population growth, etc., etc. So it's quite interesting. Okay, there is another definition for you, descriptive statistics. It can summarize the data that can be numerically or graphically to describe your sample, okay? When you do statistics on master level, you actually have a software program, SPSS, that actually do the descriptive statistics for you automatically. Your inferential statistics is used to model patterns in the data. It accounts for randomness and it draws conclusion about the larger population. Correlation, um, statistical analysis of a data set may reveal that two variables, okay, that is, two properties of the population under consideration tend to vary together as if they were connected. That is a correlation. I mark the definitions for you. It's not necessary that you know this offhand. Just mark it and know where it is in your file. Should you get a question, what is a correlation in statistics? Then you know immediately, page 293, you go to your statistics. I marked everything in pink and the description is in yellow. Okay. In a sample, if a sample is representative of the population, then inferences and conclusions made from the sample can be extended or extrapolated to the population as a whole. Okay, a major problem determining the extent is the sample representative? Does the sample represent the whole population? So that is also an important aspect. There's an example for you on correlated where the arrow is. An example for you if you want to use an example of correlation. There's activity 2.2. Again, please do so. Please, do the activity. If there's any questions on the activity, just let me know. If I can help you in any other way, if something is unclear. Outcome, sample space. Okay, outcome, sample space, and events. Here's another definition. Outcome is one of several possible results in statistics. Sample space is the set of all possible outcomes. If you wish to obtain a certain number, you call this number an event and you will mark it as E. Okay, so the number of outcomes in the sample space is called NS. This is how you write it up. Okay, and an event is N in brackets E. Okay. This I just want to quickly go through. Let's say you have 9 balls in total and you want to remove 2 red balls. Okay, how will you write it up? The sample space is, and then you have all your balls because there's 2 red balls, 1, 2. There's 3 blue balls, 1, 2, 3. Okay, there's 4 green balls, 1, 2, 3, 4. Okay, so it's 9 balls in total. The number of outcome in the sample space is NS and it's 9 because in total you have 9 balls. Taking out a red ball is an event. There are only 2 possibilities. So E equals 2, red ball 1 and red ball 2, and you will write it statistically N in brackets E. That's the number of the outcome equals 2. Okay, it's just they might ask you that. I don't really think they will, but okay, just be prepared and know where it is on page 295. Activity 2.3, you can also do that. It's exercises, how to write the measurements up. Then the probability formula. Okay, I'm going to discuss this in my notes clearer. Okay, the probability of an event, E, is found by, okay, PE is the probability of the event, and NE is the number of outcomes in the event. So you take your probability of event equals the number of outcomes of the event divided by the total number of possible outcomes, your sample space, okay? And it's logical if you think about throwing the dice, okay? You have 1 in 6 chances to throw a 6, okay? The number of outcomes in the event will be 1 since you only have 1 outcome of throwing the dice, okay, then the total number of possible outcomes will be 6 because this dice has got 6 sides. So you will write using that formula, the probability formula, to write the findings up. You've got one probability, okay, you write it up as the NE is the total number of possible outcomes, the sample space, divided by, or let's say, yeah, divided by NS, which is the total number of possible outcomes, your sample space, and you will write it up 1/6. Okay. There's another example for you. I just want to stay in the call, get back to the screen. Okay. Now the laws of probability. There's 3 laws of probability. I also marked it in the notes in detail. If the probability of an event occur, and it's the probability of an event, okay, the probability of the event not occurring is 1 minus P in brackets E, okay? So what is the probability of not throwing a 6 on the dice? The probability of throwing a 6 is 1 to 6. The probability of not throwing a 6 is, you will write it up, okay? So it is 1 minus 1 by 6, and it equals, because you deduct the 1, so your probability of not throwing a 6 will be 5 out of 6. I hope this makes sense, because it's 1 minus 1 out of 6, so it will equal 5 out of 6. Okay, and this answer is again in the probability formula that was used. Okay, so you will have NE is the number of outcomes in the event. So you will throw, let's say 1, 2, 3, 4, 5. You have 5 numbers that you can throw instead of a 6. And then the number of possible outcomes is 1, 2, 3, 4, 5, 6, because the dice has got 6 sides. Okay, so this is the formula how you will write it up. P, the probability of not throwing a 6, you will write it up as NE is the number of outcomes in the event is 5, and NS is the number of possible outcomes. Okay. Law 2 is the mutually exclusive events. Okay. It's impossible for them to occur together. Mutually exclusive events cannot be independent, and vice versa. Okay, so this is what a mutually exclusive event is. How you will write it up, you have a probability of event A or a probability event of event B. It equals probability of the event A plus probability of the event B. Okay, so again, you will have your sample space, okay, number of possible outcomes of the dice, 1 to 6. So event A, okay, let's say event A, you can throw an odd number, 1, 3, 5. Event B, you can throw an even number, 2, 4, 6. The probability of either occurring is 100%, since event A and B are the same in the sample space. Okay, it happens together. So you're going to write it up as the probability of A or B. Okay, so this is how you write it up: probability of A plus probability of B. So it's 100% that they have a chance. So out of 6 sides of the dice, they can have 3. Remember, the events is occurring together. They have 3 chances, okay, of throwing an odd number, and event B has also got 3 chances of throwing an even number. So that equals 1. So each of them can throw an odd number, or each of them, or A can throw an odd number and B can throw an even number. Each of them has got a 1 number. I will explain this to you better in the notes. Okay. Law 3 Independent events, okay? Two events are independent, okay? The occurrence of one of the events gives us no information about whether or not the other event will occur. The events will have no influence on each other. If the events are independent, simply multiply the individual probabilities by each other, and you will write it up as, okay, that's a probability of event A, okay, and you multiply it by the probability of the event B. Okay, let's look at the example. A man and a woman each have a pack of 52 playing cards. Find the probability that they will both draw the ace of clubs. Okay. So A, the probability is there's 52 playing cards. So it is, again, the probability is 1 out of 52 cards. B, the probability that the woman draws the ace of clubs is also 1 out of 52. Now, event A and event B is independent of each other, okay? You will write the findings as probability of event A multiply by probability of event B. So it's 1 in 52 by 1 in 52. Okay. Now, if you take 1 and you divide it by 52, it gives you 0.019. If you times it with 2, it gives you 0.00037. There is your answer. So the probability that the man and the woman will both throw an ace of clubs is 0.00037. It's a very small chance that they will both throw the ace of clubs. Okay. In general, mutually exclusive events are characterized by words, okay, either or, any, and. Okay. Independent events are characterized by words and both. Sorry, that and must come away. So the words is either or any. Independent event is and both. Okay. Please do activity 2.4. Working with the analysis, working with data and analyzing the data. This is a nice exercise for you. Activity 2.5. Do activity 2.6 and activity 2.7. It's just a revision of all the work. And then you have your self-assessment questions on page 304. I please want you to do the self-assessment questions. I didn't write the answers for you because I want you to go through the work and also the notes that I gave you, and you have to answer these questions in your file because this will help you to get familiar with the content, and you're going to definitely get answers, okay? In the exam, there's the references, okay? So you're definitely going to get answers of statistics. In my second training session, I will quickly go through the notes that I made for you. You can print this out and put it at the back of chapter 5 and use those notes, okay? Because you're definitely going to get statistics. I can remember when I marked the N2F4 exams, that was still for the EAAB in 2019. They asked a lot of statistical questions, and I also know how they structure it. So in my next session on my notes, I will show you how it might be structured, that you can prepare yourself, okay? Yeah, so this is it from me. I went through the whole chapter 5 with you now, and yeah, I'll see you next time when I discuss the notes. Have a lovely day further. And remember, if you have any additional questions, you are welcome to contact me, WhatsApp or email. Okay, bye-bye.